Good morning, everybody. Good afternoon. This is the video recording of the first part of core lesson dated 8 of this morning, 18 of March of 2020, which had some troubles due to Teams and the difficulty of sharing the slides. So I will repeat the first part of the lesson, the subject of which is conceptual design, introduction to IDM model, and presentation of the sub-model C-IDM. This is the content of the whole lesson. This is the overall outline that I plan to do in the lesson this morning. So try to discuss what is web conceptual design and why we need a language for web conceptual design. Then an overview of the IDM interactive dialogue model for web design with its dialogic metaphor, its design dimension submodels. Its submodels are called C, L, and PIDM, and then a focus on C-IDM and L-IDM. A design model is basically a language, something that allows people to communicate their design decision, to analyze them, and to report in the proper documentation. And by language, that means a set of concepts, terms, notation, and rules to use these various terms, concept, and notation. During the lecture, I ask to students if they have any example of design languages. We have probably a designer who said user-centered design is a design model or design language, which is not fully correct. User-centered design is more an approach to design in which you always have humans at the center of your design process. Others, probably coming from engineers, say entity relationship model and UML, and this is the correct answer. The entity relationship model is a model for database design, so for designing, for describing at a conceptual level the data. At conceptual level means, and that is the characteristic of any design model, conceptual level means without considering the actual details of the implementation environments, which are going to be tackled in following design phases. So the conceptual model for a database in a sales web application looks like this picture. The main primitives for the entity relationship model are entities, such as shipping, customer, order, company, shopping cart. Entity are the basic entities, so the basic elements of your domain about which you have data. Entities can have attributes, and the second primitive is attributes, such as a customer has a name, an address, an email. Attributes should be attached to all entities. In this case, they attach only to customer for clarity, or to item, or to company. And then what is called action or relationship is basically a relationship, something that connects from a semantic perspective an entity to another one, such as, for example, an item is produced by a company produces an item. A shopping cart for a given customer contains different items. A customer orders items. Our items are ordered by customer. So the basic idea having describing the domain in terms of its basic actors, its basic ingredients, refine each entity in terms of specific data, attributes, and then connecting them through relationship. If you look at this diagram, indeed, there are two levels of abstraction. If you forget about the attributes attached to entities, you have the higher level view of your entity diagrams. When you attach all the attributes, you go into details, you go more in the small. And so you have these two steps. First, design it in the large by describing customers, shipping, by describing entities and relationship, and then go into detail of what are the specific data. Here in the entity relationship model, we speak on detailed data. We have to describe which are the specific data for each entity. As you will see, when you do web design at the level that we do with IDM, we do not have to leave to consider this level of detail. It remains at a higher level of abstraction. Another design model is UML, Unified Modeling Language. That is really a big, heavy design model that provides many visual primitives to visualize the entire design of a software system. And in the picture, you see here the multiple kinds of diagrams that you can use. Basically, UM diagrams are used to represent two main aspects of the system, two main views of the system that are called static and dynamic. The static or structural view emphasize the static structure of the system using objects, attributes, operations, or relationship. It's basically the picture of what the ingredients of my system are in terms of data, objects, attributes, functions, and operation, and how they're related. Then the dynamic or behavioral view describe the dynamic behavior of the system, what happens at runtime when the system really works either under the user control or autonomously. And the behavioral view, the dynamic behavior, is described defining how the different elements collaborate. So how for example, an object calls another object and asks for information to another object or transmit information to other objects, and changes of the internal state of object, where by internal state I mean the value of the variable that describe what the object is. So for example, if you have a product as part of a system that manages product state transaction, the amount of products of a given product in stock, so how many books I have with a given title by a given author, this is part of the state of the system. When I make a transaction, this number decreases, so the state of the object, the state of the overall system changes. According to these two different views, static and dynamic, there are two categories of diagrams. So we group UML diagrams in two big categories: those that represent the structural information about the system, such as class diagram and composite structure diagrams, and those representing the behavior of the system, and typically you have sequence diagram, activity diagram, and state machine diagrams. So as I mentioned, UML is a very broad generic model in principle for any kind of software system. So it could be used also to model website, but as a matter of fact, it's really too much we don't need to use UML to model website. We can model something simple, or at least we can use UML to model the implementation of our website. But we, in the design exercise and design project that you have to do in this course, will remain at a higher level of abstraction. So these are all the different diagrams that you have to learn to use in UML. We provide a model that which is called IDM, which meets all the requirements that a design model should have. So help to externalize idea about requirements and solution, how you solve and you satisfy the requirements, how to represent requirements and solution, how to communicate and share your design decision, and also it's a tool to analyze and reflect, brainstorm, and discuss your design problem and your design solution. So IDM stands for Interactive Dialogue Model. Was a joint effort by University of Lugano and Politecnico Milano. It provides a revised version of an older model, which is called HDM, Hypertext Design Model, which was presented in '91 at the most important conference at that age on hypertext, in which Tim Berners-Lee presented his first version of the web. It was the first official demo of the web. And basically, why did he present it to a hypertext conference, where hypertext means non-linear text? Because he was proposing to have an hypertext in which the different pieces of text were distributed on machine all over the world. And the link was not just moving from one page, from one document to another document in the same computer, but in different computers all over the world. So HYPERMEDIA was the first model to design hypertext, and was then progressively, its basic idea was taken by other models such as HYPERMEDIA, WebML, that were somehow adding new feature to address some specific issues, also at a lower level concerning hypertext in the web. Still, for the purpose of this course, IDM provides the basic concept, the basic primitive that can help you to design the key feature of your website. So IDM is based on a metaphor, a linguistic metaphor, which is a web experience is a human application dialogue. It's like a human application dialogue in which when the user selects a link, his cognitive task is asking something to the system. While when a page or a content is displayed, is the way for the system to answer to the question. So when you are in a course web page and you ask for the teacher and you get the description of the teacher, you are asking for the teacher, and the system replies with giving you the information about the teacher. So it's important that you consider this aspect in which basically what you have to do when you do web design is define all the possible questions that the user may ask to the system and model them through navigation structure, and asking yourself what are the main contents that this system can provide to the user to reply to his or her questions. And the example that we will see are from the National Gallery. So the National Gallery of Art was the first museum who digitalized its collections and created a website about the museum. And it's still one of the largest websites in the world. So when I go to collection and I click on collection, even when I simply move the mouse on it, I'm wondering, what do you have in the collection? What can I do with the content of the collection? And when I click on highlights and go there and wonder, what are your main masterpieces? And the system say, okay, I have many masterpieces. I have 121 masterpieces. I split them in different pages. Every page contains 48 masterpieces. And then the system can say, wow, can you tell something more about Andrea del Castagno? Okay, the system answers by telling you, okay, I have many information about Andrea del Castagno. I have a picture, I have the title, some technical information, an overview, and more. Because and the user can say, well, where does this painting comes from? What is its provenance? So when you go and click on provenance, the system replies by providing you information about provenance. Or when you want to have some scientific references about this painting, you can ask, do you have any bibliography about this? And say, yes, I have many scientific references about it. And if you notice, it's really a continuous, you can model the situation as continuous question and answers. And by the way, if you go to other highlights, for example, if you take this painting by Alfred Stieglitz, who is an American painter and art curator, you see that in this website the contents are very clean, and you have some parts of the topic of the description of the components are similar among the different elements. If you take another important painting, such as we take this painting by Goya, again you see a very similar structure. That means that when you design a large application, you have to classify the type of content about which the application can speak, and you have to classify the types of questions that the system is able to, the user would pose and the system is able to reply, so that you do not work page by page, but you work by defining classes of subject, classes of questions, and structure that apply to different contents in the same type. So we are not working page by page, we're working by thinking about categories of question and categories of content. Back to our slides. The rest of the video, the rest of the lesson, which is presented in the video that was recorded this morning, basically describe the key feature of HDM. So what are the aspects that HDM address, which are content, navigation, and presentation. IDM does not model operations, as we explained in detail in the other video, and is organized into a number of submodels. That is the end of our re-recording. So I stop now and please continue with the other video. Thank you.